So to answer question number one, they give us the wavelength of red light, and that wavelength is 710 nanometers. Now, whenever we're working with electromagnetic radiation, a lot of times we work in nanometers. And so I give you the conversion factors up here. So 1 nanometer is the same thing as 10 to the negative 9 meters. Or if you go the other way around, you could say that 10 to the 9 nanometers is 1 meter. And we're going to need that information to solve this problem because whenever we're talking about frequency and later energy, we need our wavelength to be in meters, and so we have to do a conversion. So um, if we want to know what the frequency in hertz is of red light having a wavelength of 710 nanometers, we're going to use our basic formula here that the speed of light equals the wavelength times the frequency. And so I'm going to just rewrite that equation there to isolate frequency because it says what frequency we want. And if I take the speed of light and divide that by the wavelength, that will give me the frequency. So my speed of light, I give you that in Wiley's text. He gives you 3.00 times 10 to the 8 meters per second. You can see that that's actually the same number. It's just this just has one more significant figure. If you rounded that up, you would end up with 3.00. So I have 2.998 times 10 to the 8 meters per second. I'm going to divide that by my wavelength, which is 710 nanometers. That's what we've given there. But I need to convert nanometers to meters. And so I know that 1 nanometer is the same thing as 1 times 10 to the negative 9 meters. So whenever I solve this problem, I take 2.998, divide it by 710, divide that answer also by 1 times 10 to the negative 9, and I come up with 4.22 times 10 to the 14 hertz. And hertz, as you will notice, it could be written in per second, or it could be written as a hertz, either one. So that's answer to question number one.